In this video, we're going to discuss about the one-sided limits. So, na-encounter na natin yung one-sided limits dun sa differential calculus natin or calculus 1. Okay, so ano nga ulit yung one-sided limits in terms of epsilon delta definition? So, for definition, let A be a subset of R and F be a function from A to R. And if, for number 1, if C, a real number C is a cluster point of this set, the intersection of set A and C comma infinity, so that means ang pinag-uusapan natin ay yung mga values ng X na nasa right side ng C. Okay? Then L, element of R, is a right-hand limit of F at C if for any positive epsilon, there exists a positive delta such that for all X element of A, 0 less than X minus C. So as you can see, nawala yung absolute value dun sa definition ng limit less than delta. Ba't kaya nawala yung absolute value? Kasi nga, yung X dyan ay yung mga nasa right side na lang ng C. So yung X ay greater than C. Always greater than C dito sa part na to. Okay? Less than delta implies absolute value of f of x minus L less than epsilon. So yan pa rin yung definition ng limit, no? Ang nangyari lang, nilimitahan natin dun sa right side ng C yung values ng x. And we write limit of f of x as x approaches C plus or for C from the right equals L. Then for number 2, almost similar sa number 1, if C is a cluster point of this set. So dito naman, intersection ng A and negative infinity comma C. So ito yung mga nasa left side ng C, yung mga mabababang values of X kaysa sa C. Then the real number L is a left-hand limit of F at C if for all positive epsilon there must exist positive delta such that for every X element of A, 0 less than C minus X. So as you can see, C minus X na siya kasi nga yung C natin ay mas mataas dun sa values of X. Okay? Yung X kasi dito yung mga nasa left side ng C. And as you can see, wala din siyang absolute value. Implies the absolute value of f of x and L less than epsilon. Okay, and we write limit of f of x as x approaches C minus equals L. So, madali na lang intindihin yung definition kasi nga na-preserve lang naman yung definition ng limit. Ang naiba lang ay dun sa values ng x. Kasi dun sa right hand limit, nawala yung absolute value kasi nga yung x dito, mas malalaki naman na siyang values kaysa sa C. Kaya x minus C. Dito naman, C minus x, naging C minus x kasi yung mga x dito, yung mga mas mabababang value kaysa dun sa C. Okay? Now, meron tayong theorem dito. Let A subset of R, let F be a function from A to R, and let C element of R be a cluster point of both A intersection C comma infinity, yun para sa right hand limit, and A intersection negative infinity comma C. Okay? Now, yung limit daw ay nag-e-exist and that limit is L if and only if yung right hand limit ay equal sa left hand limit at yung limit na yon ay yung L. Okay, so alam na natin yung ganitong theorem sa differential calculus pa lang. Okay, so hindi ko ipoprove tong theorem, magbibigay lang ako sa inyo ng example. Okay, so example tayo, number 1. So, let's say meron tayong piecewise function, f of x is equal to 1 if x is greater than 0, 0 if x is 0, and negative 1 if x is less than 0. So again, yung function na to, yung piecewise function na yan, ang mas kilala natin yan sa tawag na signum function. Okay? Now, show using the right hand and left hand limit, show that limit of f of x as x approaches 0 does not exist. Not exist. Okay, and using the theorem also. Okay, so for our proof, okay, so mapapansin natin, yun dito kasi, yung kapag kinuha natin yung mga x values na nasa right side ng 0, or that values ay yung mga positive, ang palaging magiging values ng f of x dyan ay positive 1. So that means, yung limit ng f of x as x approaches 0 from the right is equal to 1. Bakit? Since, by definition ng right hand limit, for all positive epsilon, let's say choose tayo ng values ng delta. If let's say yung delta natin is 1, kasi sabi nga sa definition dapat may mag-exist na delta. Let's say yung delta na yun ay 1, then 0 less than right hand limit pinag-uusapan natin, so x minus 0, so yan yung x minus c, less than 1 implies absolute value of f of x minus L less than epsilon, which implies absolute value of yung f of x natin ay positive 1 minus ang L natin dito ay 1 less than epsilon. This implies 0 less than epsilon, which is true. Okay? So, kaya natin nasabi na yung limit ng f of x ay 1. And then, on the other hand, yung limit ng f of x as x approaches 0 from the left is negative 1. Since, by definition of left hand limit, for any positive epsilon, let's choose again delta equals 1, then 0 less than 0 minus x less than 1 implies absolute value of f of x minus L less than epsilon, and this implies yung f of x natin ay negative 1 minus L is negative 1 less than epsilon, and that is also negative 1 minus negative 1, that is negative 1 plus 1, and that is 0 less than epsilon, which is true. Okay. Now, as you can see, yung right hand limit is 1 at yung left hand limit is 1. So by the theorem, since yung limit ng f of x as x approaches 0 from the right is not equal to the left hand limit 0 from the left, so therefore yung limit ng f of x as x approaches 0 does not exist.